Hello students, today we are going to study about continuity and differentiability chapter, and in which we have to study about differentiability. So first of all, I'll explain you what is differentiability. Differentiability, as you can remember this one, like here ability is here differentiation is there, means ability to differentiate. So what is the definition of this one? Differentiability is derivative of function at point C in its domain. Here you should note down this one. We have to write in its domain, means derivative of function at point C. Point C is lies in its domain value of a given function. So suppose we are considering a sine of function, then we have to consider the point C which lies on domain value of a sine of function, which is denoted by f dash c. So derivative of function at that point is denoted by f dash c, or you can simply write it ddx of given function at point c is defined by f dash c is equal to limit h approaches to 0 f of c plus h minus f of c upon h. You know this one formula in limit. This is limit h approaches to 0 f of c plus h minus f of c upon h. You studied this one formula and differentiation, that is by using first principle. So your differentiability or derivative of function at that point f dash c, or you can say f dash c, is always equal to limit h approaches to 0 f of c plus h minus f of c upon h. This is your formula to find the derivative at a given point. So here some key points are there that you should note down. This one, very first point, derivative of a given function. Derivative of given function means if you are finding the derivative of given function, then you should note down this one. Derivative of a given function exist only if the limit exists for that function. If existence of limit is there for that function, then we can find derivative of that function. If limit is not exist, then we cannot find the derivative of that given function. And second point, a function is differentiable. A function is differentiable at point C in its domain if any function is said to be differentiable at a given point C in its domain if and only if their left-hand derivative, I'm saying again, this is left-hand derivative. Left-hand derivative is equal to right-hand derivative. What is this? That is, left-hand derivative means limit h approaches to 0 from negative side f of c plus h minus f of c upon h is equal to right-hand derivative. This is right-hand derivative. See, limit h approaches to 0 positive f of c plus h minus f of c upon h. If both left-hand derivative is equal to right-hand derivative, but you should note down this one, this left-hand derivative is equal to right-hand derivative is equal to any finite value, not infinite value, only finite value. Means function is differentiable at a given point C in its domain if their left-hand derivative is equal to right-hand derivative is any finite value. Both derivative should be equal to finite value, not infinite value. Okay, now next point, a function is said to be differentiable in an interval if we are considering closed interval AB, any function is said to differentiable in closed interval if it is differentiable at every point of closed interval AB. Means a function is said to be differentiable in an interval AB if it is differentiable at every point of A and B. With closed interval means we are including here value of A and B also, and all the values that lies between A and B. Then function differentiable at every point of closed interval AB. Or for open interval, similarly we can say that a function is said to be differentiable in an interval, open interval AB. Open interval means we are excluding A and B and we are considering only values which are lies between A and B. Here we are considering all the values including A and B and also those values which lies between A and B. But here we are excluding A and B. We are considering only values which are lies between A and B if it is differentiable at every point of a open interval. So again I am saying you that of differentiability, if I have to check the differentiability at a given point, then what we have to check? Firstly we have to check their limit is exist or not. If limit is exist, then it means their left hand derivative should be equal to right hand derivative equal to any finite value. Means firstly we have to find the left hand derivative, then we have to find the right hand derivative. If they are equal to each other, equal to finite value, then we can say that a function is differentiable at that point. Otherwise function is not differentiable at that point. Okay, thank you. In my next video I'll explain you a theorem that is every differentiable function is a continuous function, but every continuous function is not differentiable. Thank you. Have a nice day.